Welcome back to my channel, guys. Today we are solving yet another LeetCode problem called lowest common ancestor of a binary search tree. This is a hard problem, so let me just explain. It's medium, but binary search is always hard, especially for me personally. It's always hard. Not just binary search, but binary search tree. So given binary search tree BST, find the lowest common ancestors. So lowest common ancestor is defined between two nodes P and Q, descendant P and Q as descendant. Let's say P is 2 and Q is 8. P is 2, Q is 8. So we need to return this ancestor of these two, which is 6. So the common node between these two nodes, which is 6, we can say the common node. And in this example, we can say this is the tree, and we say P is 2 and Q is 4. P is 2 and Q is 4. So what is the common ancestor of P and Q? So P and Q. So it could only be 2 because 2 and 4, they have the same. We cannot go back to 6 because 6 doesn't go directly. It's not the direct ancestor, it's indirect ancestor. So 2 is in this case, we will return 2. So let's get started. So in tree node, you can see there has an int val, tree left, tree right, and then that's a constructor right there. So we're gonna solve this. First, we're gonna get int parent val. Parent val equals root dot val. So we got the value of the root. Root is this, and if in the case of this subtree, this is the root. Okay. So we're gonna have to check if p dot val, which could be this, if it's greater than parent val, and q dot val also has to be greater than parent val. So why both of them apply to the same condition? Because for you to have the same ancestor, you need to be on the same subtree at least, okay? Like in the same subtree like this. So we check if the value of the parent is greater than. If it is, then we return lowest common ancestor. And then if it's, in this case, both P and Q are greater than parent value, right? So that means they are on the right side, because in binary tree, any element that is greater than the root has to be on the right side of the root. Okay, that's just binary search. This is binary search tree. Okay, so we're gonna return root dot right, and then we're gonna pass in P comma Q. So we send those two as well. So else if P dot val is less than parent val and q dot val is also less than parent val. In this case, we return, we do recursive call to return ancestor of root dot left p comma q. Otherwise, the else statement checks if they have the same. Let's say if one of the p or q have the same, are from the same descendant, like 2 in this case. 2 is the node, one of the node that is given, and then also it's the descendant. So in that case, we can do return root, because we need to return a tree node, so we just return the root. Let's run this. Accepted. Perfect. It's a bit hard to understand binary search tree and all these recursive methods. They're a bit confusing, but at the end of the day, it's just keep trying, and if you don't understand anything, just leave comments or just go do some research like binary search tree. Then once you start to understand a little bit, then you can start to solve the problem. And once you are able to solve the problem, you're gonna love this. This is amazing. These problems are amazing. Thank you, guys. See you next time.